Let's look at handout on section 4.6b, rates and related rates. Now, this problem, he says we should be able to solve it now, so let's work through it. A sailboat 3 miles east of Port Washington is sailing at this speed, and this one is sailing at this speed. At that moment in time, is the distance between the sailboat and the motorboat increasing or decreasing? At what rate? So let's draw the diagram. We have the sailboat coming toward Port Washington. He's 3 miles east, and he's traveling, I'm going to say ds dt, at 4 miles at 4 miles per hour. Now I believe that's going to be a negative 4 miles per hour. All right, then we have a motorboat coming toward Port Washington as well, and it's 4 miles away. And the motorboat is 12 miles per hour. Okay? And again, I think we want to call that negative because it's going toward Port Washington. Now, the equation we're going to use is Pythagorean theorem because this is a right triangle. So we're going to say the sailboat side plus the motorboat side squared equals the distance between them squared. Now, at the time this is happening, we want to know that distance. So 3 squared is 9 plus 16 equals d squared. D is going to be 5. So we need to know that. Okay? Now it says identify the rate of change you're looking for. They want us to find the change in the distance between the sailboat and the motorboat, ds dt. I'm calling dt, a little bit of a mouthful. What is that changing when d equals 5, s equals 3, m equals 4, ds equals negative 4, ds dt of course, and dm dt equals negative 12. So the equation we're using is again that Pythagorean theorem, which we will implicitly differentiate with respect to time. So it's 2s ds dt plus 2m dm dt equals 2d, so I should say dd dt. We want dd dt. So let's substitute in what we have. So 2 times 3 times negative 4 plus 2 times 4 times negative 12 equals 2 times 5 times what we're looking for, dd dt. If I do this problem and solve, I end up that the rate of change of that distance between them with respect to time equals negative 12 miles per hour. I think that's right. We ended up with negative 24 minus 96. Yep, should be negative 12 miles per hour, which is interesting because 2 times 3 is 6, negative 24. Well, it seems to work. Seems to work. So this is the rate of change of the distance between those two boats. All right, a man launches his toy rocket 15 feet away from his remote control. It gains an altitude at this rate, which really is dh dt, right? And find the rate at which the elevation is changing when he has an altitude h equals 15. So let's draw that diagram. All right, so the rocket's shot up here, right? And here's the guy with the remote control. This is 15. We want to know d theta dt d theta dt. And we know that dy dt is 2.5 feet per second. They gave us that. And we want to know that when the h is 15. All right. Again, we're looking for d theta dt. We know x equals 15, and we know dy dt equals 2.5 feet. And we're finding that rate when y, or h, I'm going to say y at this is 15. Okay, we're going to write a relationship equation now. We know that tangent of theta on our picture, which is 15, and this is y, we're going to call it equals y over 15, right? Okay, one thing we did have to figure out, well, let's implicitly differentiate it out with respect to time. Oh, I noted, this is 1, I changed this to 1 over 15y. So the derivative of tangent is secant squared theta d theta dt equals 1/15 dy dt. Okay. Now, when they want to know it when y equals 15. So this is going to help us get theta. We want to find this, but we didn't have a theta. So when y was 15, x was 15, we get the tangent of theta equals 15 over 15. So at that point, theta has to be 45 degrees. Now, I don't want to use 45 degrees. I want to use basically pi over 4. We need to work in radians when we do this. So my equation, if I'm going to substitute in secant squared theta, that's really secant theta squared, which is really 1 over cosine theta squared. We needed to get that. So in radians, cosine, oops, I didn't want that. I want cosine of pi divided by 4 is 0.707 times 2 is this, and then 1 over that number. I'm going to do this. Take that. All right, I'm going to take this number, 1 over that number. Okay, cosine of 45 is 0.707, or pi over 4. I squared, it's 0.5, 1 over 0.5. That square should be in there. 1 over 0.5 is 2. So the secant squared of theta is 2. So my equation really is 2 d theta dt equals 1 over 15, and the rate dy dt from the other page was 2.5. So I'm going to do 2.5 divided by 15, and I'm going to divide that by 2. So what we get is that this angle's changing 0.083 radians per second. When you work in these, we need to do radians. Okay? It seemed low, but I did a kind of a crude check, and it seems to work. Okay? Let's look at this one. We have an elevator that's moving, and again, we're looking for we want to determine how many radians per second. We want d theta dt when the elevator is 100 feet above the ground. Let's see, when the height is 100. Which really, when the height's 100, we actually are directly across from the window here, aren't we? All right, the hotel is 300 feet high, and you are across the street. You are 100 feet off the ground and 150 feet. All right, so let's see. Identify the rate of change you're looking for. We want d theta dt when h is 100, and we know dh dt equals negative 30 feet per second. Okay. Again, we're going to use the tangent of this But one thing we do need to know is when y equals 100, or h equals 100, and we're directly across, our angle is 0, right? Theta is 0. And that's something we're going to need on the next page. Oops. Let's figure out our equation. Tan of theta this time, if I look at here, h, and this is 150. So tan of theta equals h over 150, or 1 over 150 times h. Okay, let's differentiate it. That's on the next page. So tan theta equals 1 over d dt. This is secant squared theta d theta dt equals 1 over 150 dy dt. All right, and when we said when the elevator is 100 feet off the ground, the angle itself is 0. Okay? All right, and the cosine of 0 is 1, squared is 1, so secant squared is 1 over 1, or 1 of 0. All right, secant squared of 0 is 1, d theta dt equals 1 over 150, and the change in the height is negative 30 feet per second. Okay, this answer should come out in, I believe, radians. Oh, they want it in radians for a second. Okay, well, I think it should work. So it will be 0.2 radians per second. I'm going to check the units on that, but I'm hoping when the way we set this up, see how the theta of this angle equals y over, this is really 150y, y over 150, you get feet and feet to cancel, and really radians is a unitless measure. So that's why we should have had that all cancel out in here, and radians should be a unitless measure. Okay? Well, let me know if you have any questions.